Assalamu alaikum. I am Dr. 𝐒𝐤𝐞𝐭𝐜𝐡. Welcome to my channel. In this lecture, we will discuss how to sketch the region of integration, how we can reverse the order of integration, and after that, we will learn to evaluate this integral. This question is question number 51 from Thomas Calculus 12th edition book, exercise 15.2. So, in order to sketch the region of integration, first of all, we need the equation for the boundaries of our region, and these equations are obtained from the limiting values of our inner and outer variable. In this question, our inner variable is x, and the limits of x are y by 2 to square root of natural log of 3, and the limits of outer variable y are 0 to 2 into square root of natural log of 3. So we will equate these limits with the variables. So y equal to 0 will give you the first boundary, and y equal to 0 is equation of x-axis. Y is equal to 2 into square root of natural log of 3 will be an equation of horizontal line. When you plot it, you will get a horizontal line. Y is equal to x over 2 is a journal line which passes through ordered pairs like this: 0, 0, square root of natural log of 3 to natural log of 3, and x is equal to square root of natural log of 3 will be equation of vertical line. Since in this question both x's are not involved in our boundaries, so first of all we will make them as dotted lines or with dashed lines. After that, you can see from the equations y equal to 0 is involved in our boundaries. Y equal to 0 means our x-axis, so we make our x-axis with bold lines, or we will convert our x-axis from dash to bold line like this. After this, we will mark our x-axis, y-axis, and origin, and then we will mark these points: square root of natural log of 3 along x-axis and 2 square root of natural log of 3 along y-axis. You can easily calculate this value through your calculators. Now we will plot the vertical line: x is equal to natural log of 3, and then horizontal line y is equal to 2 square root of natural log of 3. Now the point of intersection of this vertical and horizontal line means this point is square root of natural log of 3 into 2 square root of natural log of 3. In the next step, we will plot this line y is equal to x over 2 by joining these two corner points. So after joining origin and this ordered pair, square root of natural log of 3, 2 square root of natural log of 3, we get our region of integration. From here, you see this triangle region is our required region of integration because it is the only bounded region in xy plane through these boundaries. In the next step, we will highlight this region. So this process completes the sketching process, or the first part of the question where we have to sketch the region of integration. In the next step, we will learn how to reverse the order of integration. Reversing the order of integration means we will interchange our inner and outer variable. In this question, our inner variable is x and outer variable is y. So we will interchange them. After interchanging our inner variable and outer variable from dx dy to dy dx, we cannot simply change our limits because limits of outer variable are always constant and limits of inner variable may be constant, may be variable. So we cannot simply switch the limit just like we switches our variables. So we need some new limits in order to solve this integral after reversing the order dy dx. For this purpose, we will use arrow technique. For inner variable, we will pass an arrow through this region like this. Watch it again from bottom to top. This arrow enters through the boundary y equal to 0 and exit the region through the boundary where the value of x is y over 2, or the value of y is 2x. So the limits of y are 0 to 2x. Now for outer variable x, we will check the range of region along that particular axis. So for x-axis, we will check the range of region from left to right. Our region starts along x-axis at origin, means at x equal to 0, and finishes our region, or our region completes its boundary at x is equal to square root of natural log of 3. So the limits of x are 0 to natural log of 3. The range of our region along x-axis is 0 to square root of natural log of 3. So these are the limits of our outer variable. Now this completes the process of reversal of order of integration. After this, we will evaluate this inner integral. In order to evaluate this double integral, we have isolated the inner integral with the help of brackets and changed its color so that we are focused here. Now with respect to y, e raised to power x square is constant. You can take it outside of the inner integral and we are left with dy. The integration of dy will be y, and we will apply limits with the help of fundamental theorem of calculus, upper limit minus lower limit. Now e raised to power x square into 2x minus 0. Simplifying, we are left with limit from 0 to natural log of square root of natural log of 3 e raised to power x square into 2x. Since the power of exponential function has its derivative as a multiplier, that is 2x, so we can integrate this function as e raised to power x square for the limit 0 to square root of natural log of 3. In the next step, we will apply the limit. We will replace x with upper limit, minus is a formula, and we will replace x with lower limit. So we get e raised to power square root of natural log of 3 whole square minus e raised to power 0 square. Square and square root will cancel out each other. So we are left with e raised to power natural log of 3 minus 1. Since exponential function and natural function are the reciprocal of each other, they balance out each other and we will get 3 here. 3 minus 1. So our answer is 2. This concludes our question. Thank you for watching this video. Allah Hafiz.